bits of and the title of this talk is The Use of Online Educational Videos for Concept-Oriented Peer-Based Learning. Over to you, Sherif. Thanks.
Thanks so much for the presentation. I wish I could be with you face-to-face. Unfortunately, it would be hard for me to travel at that time. Hopefully in the next presentation, next conference, I will be joining face-to-face. Thanks so much for joining my presentation. Can you see my screen now?
Perfect.
Okay, so I'm gonna play my recorded presentation. I planned it to be around 10 minutes, and then I hope we will have enough time for discussion and questions. Okay. Hi everyone, thanks so much for joining our presentation. Our work is titled Use of Online Educational Videos for Concept-Oriented Peer-Based Learning. My name is Sherif Abdelhamid.
We just might need to turn up the sound a little.
No, I'll do it from here.
Can you do it from there?
Yeah, go on with the presentation.
Can you hear me?
Yes.
Yes, it's the sound. The volume of the presentation is just a little bit.
This work was conducted in collaboration with Tristan. Can you hear it now?
A bit better.
It's still quite
from Virginia Military Institute. According to existing literature, educational videos are increasingly used in education and learning, and students can learn complex concepts much better when presented with visual explanatory videos. Additionally, researchers have studied the use of educational videos for self-regulated learning, motivation, and engagement. Web 2 applications, where content is mostly created by the users themselves, are increasingly becoming popular within the last 10 years. This includes applications like YouTube, Twitter, Hi5, LinkedIn, and of course Facebook. YouTube is a rich data source which contains millions of educational videos. As you can see here in the slides, at least 90% of US internet users are between 18 and 44. 79% of users have a YouTube account, and every day 1 billion hours of videos are added. However, the availability of this huge amount of variety of online videos can lead to problems. First, to pick a relevant, updated, and appropriate one for education might be challenging for students, especially at younger ages. Also, the absence of instructor support may introduce irrelevant concepts, misinformation, and might eventually affect the student's conceptual knowledge. According to Pew Research Center, which is a think tank in Washington, D.C., and they provide information on social issues, different public opinions, and some demographic trends. In their study, they found that the majority of YouTube users encounter videos that seem false, untrue, or show people doing dangerous things. Additionally, 60% of parents report that they have seen content that was not age appropriate on YouTube. Around 80% of parents allow their children, unfortunately, to watch videos on YouTube. In this work, we are trying to address this problem and trying to fill in this gap by utilizing COUPLE, a concept-oriented, peer-based learning framework within our newly implemented system. By providing an enclosed system with content created by the community of students and moderated by instructors, we believe this approach will make the classes more motivational and significantly reduce the rely on face-to-face students lecturing. This environment will be very suitable for distant learning, improve self-regulatory learning, and it will encourage discussions, collaborative and cooperative peer-based learning. Also, it will create a safe learning environment for our students. The proposed framework is based on the Feynman technique or mental model. It can be summarized in the following statement. If you want to learn something properly, try to explain it clearly. Students will be able to identify gaps in their conceptual knowledge instantly. The proposed framework steps are: instructor identifies the learning objective, related concepts, and define assessment matrices. Students will use the Feynman technique to create videos explaining these concepts, and they can also provide constructive feedback on peers' videos. Finally, the instructor moderates the content, assign badges as incentives to students based on their interactions and engagement. The couple framework follows the motivation and activity learning series. We use the POSE series as our lens and guidance for our research. We discuss motivation as being intrinsic or extrinsic. The students using our system can experience intrinsic motivation when they feel a sense of belonging within a community of learners and instructors. Assigning students topics and concepts that are challenging to explain yet doable can be another source of intrinsic motivation. The verbal praise by instructors and peers could also be another source of intrinsic motivation. Additionally, students can experience extrinsic motivation when they are assigned digital badges on their contributions and support to others and for their peer support. A study reveals the effect of badges can differ based on the learner's ability, prior knowledge, and badge design. Another study found that badges increase student interactions and can be more useful in online courses. The second theory used by our work is the Engerstrom's approach with the activity theory. The theory explains learning and human thought processes based on the individual's social interactions with the external world through artifacts and tools. Through the implemented system, students can interact with each other and the instructor. Interactions will be mediated by the implemented system and influenced by the comments, digital badges, and the number of likes. Students as subject are interacting with other students as object to achieve an outcome, which is to help them learn about different computer science concepts. The community consists of all students and instructors. There is a division of labor, so the set of all concepts defined by the instructor are split among students to explain to others. Instructors should ensure that the students' videos are relevant and related to the concepts. Others are engaged and responding appropriately. Rewards are assigned fairly. We hope that this approach will help the entire community of learners to extend their collective knowledge. The implemented system uses a coordinating architecture that serves as a multiplexer for various components. It is a multi-tier system that consists of a web-based user interface, a database that contains information like students' profile data, educational videos, students' interactions, learning analytics tools, and a resource manager that will help connect the system to computing resources including Amazon and Google Web Services. Also, our system is integrated with external learning management systems like Canvas, so students can submit their videos, their learning materials through Canvas, which can be accessed to their instructor for grading and viewable by other students. These are some screenshots of different system pages. This page acts like the user homepage. Users can access their own videos by clicking on My Videos or view others' videos by going to the public repository. They can also see and share their assigned badges under the My Badges tab. This is another screen where students upload videos and link them to one of the topics and concepts created by the instructor. In the second screen, students can view others' videos and can comment and provide a constructive feedback that is moderated by the instructors. At the end, we would like to summarize the presentation into these main topics. Education videos are becoming more popular, but need moderation and supervision from instructors. It's important to create a safe learning environment to avoid irrelevant videos, inaccurate concepts, or misinformation. The implemented system can fill this gap by creating an online safe learning environment to our students. The research work has theoretical foundations and is guided by both motivation and activity learning theories. Future work include integration of the new framework within an undergraduate course at our CS department. We are also planning to collect and analyze data related to students' motivation and engagement. Our data source includes surveys, interviews, and data collected from our system based on the students' interactions. Thanks for joining my presentation. I will be more than happy to answer all your questions.
Great, thank you so much. I might open up the floor first if there's any questions from the floor.